Hello, this is Mrs. Vogt, and I am going to get started on the section for exponents. So we're in P3, and this is our warm-up. I would pause the video here and try the warm-up on your own. And now I'm going to show you the answer. And for number 2, when you distribute, this is what you should get. Okay, so let's review the rules for exponents. So the property name, you don't need to worry about that too much, but this is your definition. So remember, when you have like x squared times x to the third, you're going to add the exponents. The reason you're doing that is because if you have x squared times x to the third, that means you have x times x times, and then you have 3 of them. So that means we have 5 of them. So x to the 5th is what you get when you add up all of those. So we're adding them. When you have a power to a power, we have x squared to the third. Now that means that I have x times x 3 times, because x squared times x squared times x squared would be x squared to the third, and now there are 6 of them, so we get x to the 6th. So that is why we're multiplying the exponents. So this is a review for you. We can distribute the exponent here in this one. A negative exponent, wherever the exponent is negative, it will move to the opposite location. So if it's in the denominator and it's negative, it'll move to the numerator, and it will become a positive exponent, and vice versa. And then here's an example for you. A 0 exponent, a to the 0, anything to the 0 power is 1. Quotient of powers, we can show this similar example as what we did up above, but when I have something over something and they have the same base, so again, like x to the third over x squared, there are 3 x's on top and 2 x's on bottom. Since it's all multiplication, I can cancel out those, and I'm left with just x, so 3 minus 2. And if they're negative exponents, you can still do that. You just want to be careful with the minus and negative. And then a power of a quotient, we can distribute that power to both the a and the b, no matter what the base is. So now we're going to do some examples. So these are some sample questions on exponents. I would always recommend that you try it first and then watch the video. So pause the video and then try the example first, pause the video, then watch it. Okay, so number 1, we're going to simplify this. So this rule, we're going to add the exponents. This one is going to be multiplied. So we have times c to the 10th and then times c to the 6th. And that's going to simplify d to the 6th times c to the 16th. And you don't really need that times. Number 2, I'm going to distribute the exponent, so this 3 can go to both of the numerator and denominator. Now it also has to go to this 3 because this is multiplication. It has to go to every single part. So don't forget about that 3. That's a big area where we see mistakes frequently. So we're going to distribute. So I have b to the third. 3 to the third on the bottom is 27, a to the third. Okay, some more examples. Again, pause and then try them on your own. Okay, so this one we have the 2 is going to distribute to all of them. So 2 2/3 squared. The 2 is going to be squared and the 3 is going to be squared. So 2 squared is 4, 3 squared is 9. And then you have m squared squared, so that's going to give you m to the fourth, and then n squared. And that's times 1/2 mn squared. And at this point, we don't really need the parentheses because everything's just multiplication. Now we can combine our like terms. So first of all, the 4/9 and the 1/2 are going to combine, and we're going to get 4 times 1/2. So 4 times 1 is 4, and 9 times 2 is 18. And then m to the fourth and m to the fourth times m, that means I have 5 of them, so m to the fifth. And then n squared times n squared, you're adding those exponents. And then we're going to simplify this fraction, divide both top and bottom by 2. So 2/9 m to the fifth, m to the fourth. Okay, number 4, this is a negative exponent, so it's going to move to the top. And so that base and the exponent will both move. So I'm going to have 3m squared over, now there's nothing down there. We don't really need that 1, so we're just going to simplify it to 3m squared. Okay, number 5. Again, try this on your own. So you're going to distribute that 3. Make sure it goes to the 4 also. And then down here in the bottom, you're distributing it to each of those. So 4 to the third is 64. P to the third, those are going to be multiplied. 3 to the third is 27. X squared to the third, x to the sixth, and y to the third. And you're going to see if you can simplify that, and I think we are done. Okay, number 6. There's a lot of negative signs here. One thing to be careful of is just because you have a negative number, that does not mean the number moves, because that only applies to negative exponents. The negative, though, if I have 1/2, negative 1/2, it could be written as negative 1/2 with a negative in the 1, or 1 with over -2, or the negative can be out front. So when you have a negative, it can go in any of those spots. So that's just something to keep in mind there. Okay, so let's find a place to start. So I'm going to start down here with the parentheses. So I'm going to keep the 18 n to the -3rd on top. And then we have a -8, and I'm going to, you can put parentheses there, it doesn't really matter. 3 to the third is 27, and n to the -2nd to the third is going to be multiplied, so we get -6. Okay, so now I'm going to simplify. So we have 18, and there's many different ways you can do this, like orders. But we'll multiply the -8 times the 27 here, and then n to the -6th. So at this point, you can switch the order, or switch the negative exponents and make them positive by flipping them to the numerator and the denominator, and vice versa. However, you could also just subtract here. So you could take -3 minus -6, which is just +6. So you're going to end up with a +3. Either way will work. Sometimes students find it easier to just switch them and make them positive. So I'm going to do that here. Into the 6th, and on the bottom we have -216 into the 3rd. So the 18 over -216 actually simplifies, and I'm going to get 1 over 12, and that just needs to be negative. And then n to the 6th over n to the 3rd, that leaves me with an n to the 3rd on top. I don't really need the 1 there, so I'm just going to put n to the 3rd. And then this is my answer. Again, you can rewind and watch that again if you need to see it again. Okay, and then number 7, this one, notice all the bases are 2's. Same exponent rules are going to apply because the bases are the same. I'm going to make those negative exponents up here, I'm going to make those positive by putting them in the denominator. So I'm going to have 1 over 2 squared plus 1 over 2 to the first plus 2 to the 0. And now let's simplify. So this is 1/4 plus 1/2 plus 1, because 2 to the 0 is 1. We need like denominators. So I'm going to change the denominator. 1/2 is the same as 2/4, and 1 is the same as 4/4. So now I can just add the numerators, and we get 7/4. And our last example, this one's got everything all together. My advice for this one is that you want to start with your parentheses. So that's where you're going to start. And then we have to get down to one variable of each. So an x, a y, and a z. And then simplify the numbers as much as we can. So we're going to start up here with distributing this squared. So I have -3 and then 2 squared. So don't forget about that 2. I kind of forgot about that. 2 squared is 4. X to the 3rd squared. We're going to multiply the exponents. And multiply the exponents again and again. Over 18 x to the -2nd y, and then z to the 0. Okay, so let's simplify that here. This -3 and 4, I'll simplify that. So -12, we have x to the 6th, y to the -8th, z squared, over 18 x to the -2nd, y, and z to the 0, this is equal to 1. So I don't really need that anymore. Okay, so now I'm going to simplify the numbers. So -12 divided by 18, remember we're not subtracting, we're just dividing. That's going to give me a -2/3 when you simplify that. Then we have our x's. So we could move that x squared, -2, x to the -2 up to the top if we wanted to, or we could just take 6 minus -2. So 6 plus 2, which is 8. So we're going to end up with an x to the 8th. If I moved it to the top, you'd have x to the 6th times x squared, which would give you x to the 8th. And then we have our y's. That -8 can move to the bottom, or you could take y to the -8 minus 1, which is y to the -9th. So the -9th, that means that it needs to be in the bottom to be positive, because when I subtract them, it ends up being on the top, and then since it's negative, we move it to the bottom. And you can see that also because to make this -8 positive, we would move it to the bottom. And then we're left with a z squared as well. And that's our final answer. Feel free to reach out if you have any questions.